Hi, I'm Aisha from section 3B formal method, and now I'm going to talk about my system that I've developed for my assignment, which is a food menu system. Food menu system is a system that can be used in restaurants to display food menu and in display devices. It's going to help a lot for restaurants to cut costs on printing menus and also make their restaurants be more environmental friendly. Well, for my system, I've used Z-specific language. Z-specific language is the formal specific language that's perfect for describing and modeling software system. It is a set of convention that basically used for purpose of describing mathematical text, which makes it simple to use mathematics for describing a computer system. And for the tools, I've used CZD editor, which I obtained from the community Z Tools project. So before going into explaining the model of my food menu system, I will actually like to take a look at the requirements. And the food menu system has 4 requirements, and the first one is the restaurant owner should be able to add food into the food menu system, and then the restaurant owner should be able to update food in the food menu system, and the customer should be able to access the food menu system, and the customer should be able to find food in the food menu system. And now let's take a look at the code. And of course, we start by building our sets, which are food, price, address, and page. With all the sets built, we can now move to the first aspect of the system, which is the space state. This is where we declare the variables. The known variable is a set of foods that is recorded, and the food menu is a function which, when applied to certain food, gives us the price associated to them. The model system is not going to function without any operation, so it's time for us to add operations into it. So let's start with the first operation of adding food into the food menu system. For this purpose, I build the add food scheme that introduces 4 variables: known, food menu, known prime, and food menu prime. Known and food menu are stayed before the change, meanwhile known prime and food menu prime are stayed after the change. The part of the scheme before the first line gives the precondition of success of the operation. It's ensured that none of the inputs added must not already be a part of the system. This is reasonable since each food can only have one price. The second operation will be finding food. This scheme illustrates another 2 new notations. It's indicated that the state does not change in this operation, which means the value known and food menu after the operation are equal to their values before the operations. This is the first notation. And the second notation will be that the name ending in an exclamation mark for an output, which takes food as an input and gives the food menu as the output. And for the third operation is accessing the menu page, which takes the address as input and produces the page as an output. And it's also noted that neither version of database will change in this operation. And for our final operation is updating the menu where both page and address is entered as input and the working database is updated. And thank you. Thanks for listening.